Okay, so hello everyone. If you heard that noise, in this video I'm going to show to you how you can pinpoint with certainty the real culprit as to what is producing that noise. Okay, now all too often when people hear a squeaking sound when the engine is running, they would automatically assume that it is the fan belt, or in this case it's a serpentine belt. Now they would go out and buy without verifying. They would go out and buy and replace and install a new fan belt, and when they turn on the engine, the noise is still there. And that is just stupid. Now it's okay to assume, but we need to verify that assumption, okay? So what I will show you is a step-by-step process of elimination in order for us to narrow down our sight as to the real culprit of what is producing that sound. So the very first thing that you should do is to make a list of all the possible factors that may or can produce a weird noise, okay? So the noise appears when the engine is running, so we are going to take into consideration the engine itself. The crankshaft may or can produce a weird noise by reason of worn out bearings or no oil or lack of oil. So you might want to check your oil level through this dipstick. Now you would also want to take into account this fuel pump, this hydrovac right here that is producing a vacuum in order for you to operate your brake more smoothly, and that, I don't know if you can see that, below this fuel pump there's the hydraulic pump that is powering up your power steering. Now outside the engine, we need to take into account the magnetic clutch pulley of the AC compressor, this idler pulley right here, and that tensioner pulley that applies tension to your serpentine belt. Of course, we need also to take into consideration the alternator, okay? That's the alternator right there. The clutch fan, as well as its pulley, and last but not least, the belt, or fan belt, or serpentine belt in this case. Now, when it comes to the alternator, this is the alternator. It can or may produce two types of noise. One is mechanical noise, and two is electrical noise. Mechanical noise can be produced by a worn out clutch pulley assembly of the alternator or worn out bearings inside it. And when it comes to electrical noise, the best analogy that I can provide you is that if you have observed during a blackout situation, it becomes also silent, and when the electricity comes back, even if you do not have any appliances running, you will somehow still hear an ever so lightly humming or buzzing sound. Now that is the sound produced by the electrical current that is coursing through the electrical lines. Now to show you an example of what electrical noise is, I have this welder right here, and should I turn it on, we can hear the fan already turning. Now should I turn this knob to 80 amperes, we will hear a buzzing sound. See, you hear that? And as the ampere is increased, the buzzing becomes louder as well. So that is the best example that I can think of when it comes to electrical noise. Okay, so now that we have determined all the possible factors that may or can produce a weird noise, we can now rule each one out. So the first thing that we're going to do is try to check our clutch fan. We would want to try to turn it, see if it turns smoothly. It should drag, but that drag should be smooth, okay? However, if your clutch fan is going to freewheel, if you're going to turn it like that, then you have a worn out clutch fan. So in this case, it's dragging, but it's smooth. So we have no problem here. Another thing that we can do is to perform a visual inspection of the belt itself, okay? And then another thing that we can do without even having to start the engine itself is to check our clutch pulley assembly of the alternator, okay? Now the way we're going to do that is that we need to understand that this is not a single piece assembly, okay? This is a two-piece, more or less a two-piece part. This should, if you're going to turn it clockwise, it should turn. Now be careful when doing this, you might cut yourself. The edge tends to be sharp. It should turn I hope you can see that. It should turn clockwise. However, if I'm going to reverse that, it should lock itself onto this pulley right here. You should not be able to turn that. Okay? So again, clockwise. I'll try to turn it counterclockwise, and it is turning. So right from the get-go, I already know the culprit. I have a worn out clutch pulley assembly of the alternator. I hope you can see that. However, if your pulley is a single solid pulley that is directly connected to the shaft of the rotor of the alternator, then you can rule that one out, like this alternator on my 4D56 engine. So again, I'll show you. It is really turning. So I can already say that I have a worn out clutch pulley assembly of the alternator. However, if that is not the case, we're not going to rule this one just yet. We'll perform a few more tests. So the next thing that we'll do is we'll get inside our cabin, turn the engine on. Okay. And we want to rule out if it's a hydraulic pump problem. So the way we do that is we're going to turn our steering wheel hard left to hard right, vice versa, okay? And if you hear an increase in pitch of the noise when you turn the steering wheel, then you can also already say that it is caused by the hydraulic pump. Now the next thing that we're going to do is to turn on our AC, engage our AC compressor, and try to listen if there is a difference when we engage the AC compressor as opposed to the AC compressor not engaged. So in this case, there is no increase in either pitch of the noise. I'll show you on the engine bay, okay? This is off. So right now the magnetic clutch of the AC compressor is not engaged. You see, it's not turning. It's only the pulley that is attached to the serpentine belt that is freewheeling. Okay. Now should we turn our AC on? The magnetic clutch has engaged. Now you can see it already turning, but there is no difference when it comes to the pitch of the noise. Actually the noise is still there. I don't know if you can hear that, but I can already say that it's being caused by a worn out clutch pulley assembly of the alternator. And I will even dare say that it's not giving a charge, okay? But that's a subject for another video. Okay, so for now we can rule out the AC compressor. So what we're going to do next is we're going to disconnect the harness that is applying power to our AC compressor. Okay? See? The sound disappeared. Now that is what I'm talking to you about, electrical noise. When you plug this harness, it's going to produce a magnetic field over the rotor, and that magnetic field over the rotor is going to spin as the engine is running, and that interaction is going to produce AC current, and that will be the subject for another video. So I will plug this again. You see? I will unplug it. Now if the noise is too loud, and when it is plugged and when you unplug it, it disappears, you might have a diode problem. But that will be the subject of another video, okay? Now say for example, after doing all that, you could not rule out anything out. So what we're going to do next is we will turn off our engine, okay? And we will take the fan belt, or in this case a serpentine belt, out. Okay, so before we do that, another thing or trick that you can do to rule out if it's the noise is being caused by a worn out fan belt is to apply a little bit of water over this fan belt, only on the fan belt, okay? Do not, as much as possible, do not hit any part of the bearings, only on the outside of the fan belt as well as the inside of the fan belt. Now you can do that with a spray bottle, fill it up with water, just apply a little bit of water outside the fan belt as well as the inside of the fan belt, and try to observe and listen if there's any increase or decrease of pitch in sound of the noise. Okay, now should there be any considerable increase or decrease of sound, then you can rule out that it is caused by a worn out fan belt. Now we're going to remove the fan belt itself, or the serpentine belt. I'll show you how. So before we do so, it is good practice to remove the negative terminal of the battery. Okay, so we would eliminate the possibility of shorting anything out. So we also need to remove the air filter housing. Okay, and we are going to remove this harness. Okay, now it's only attached by 2 bolts, 12mm bolts, one on this side and one on this side. Okay, very easy. Okay, so the next thing we need to do is to loosen the hose clamp on this side as well as on this side. Just loosen it a little bit. Okay, push the hose out. Okay, now we can take out the air filter housing. Very easy. See? So the next thing that you will need is a 14mm wrench, similar to this one, preferably flat, and a pipe, so for you to have more leverage. Okay, now we're going to have access on the tensioner belt right here, tensioner pulley. Okay, so I'm going to insert my 14mm wrench. Okay, and then I'm going to insert this pipe right here so that I will have more leverage pulling the tensioner pulley down. Okay, the way this works, should I pull this up right here, the tensioner pulley is gonna go down. Okay, I'll show you. Okay, so I'm going to pull up on the other end of the pipe. This tensioner pulley is gonna go down. Okay, do this slowly but confidently and with conviction. Okay, and you will feel that you have overcome the tension of the tensioner pulley, and that's the time that you can pull the serpentine belt out. Okay, and then you can release it like so, and that's it. Okay, so I'm going to remove the 14mm wrench. Now we can pull out the serpentine belt. We're going to wiggle it and slip it through this fan belt. It's very easy. And now the serpentine belt is out. Now before you fully condemn and buy a new one, replace this, we are going to conduct a few more tests. You would want to check each pulley. Okay, in this case we'll start with the AC compressor. We will try to turn this, see if there's no drag, see if it's turning smoothly, see if there's no significant play. Okay, in this case there's none. Okay, what you're checking for is freedom of movement and no play and no drag. Okay, this idle pulley right here, there's also none. Okay, so we can rule that out as well. In this case there's also none. This is another idle pulley, and then we're also going to turn the pulley on the tensioner pulley. Okay, and also there's none. There's no significant play, there's no drag, it turns smoothly. Now we're going to also turn the pulley of the clutch fan. Check for freedom of movement. Okay, so this case is smooth. And so in the beginning of this video I showed you that my suspect for this noise is the alternator pulley. Okay, I'll try to show you a much better angle. See, this is turning and this right here, okay, should turn. If you see inside the fins of the rotor is turning. Okay, now should I stick this inside the alternator housing, I'm going to jam the main shaft. Okay, you see, but I'm holding this one. Now should the engine turn, if I'm going to turn this should not freewheel. This should lock itself on this side of the pulley right here. This side is connected directly to the shaft of the rotor of the alternator. Okay, see, I'm going to turn this one. It's turning, see, but this is the one that is being driven by the belt. Okay, now should I turn this clockwise, it should lock. In this case, it's not locking. However, this should turn freely when I'm going to rotate this counterclockwise. However, if I'm going to do this clockwise, it should lock itself onto this assembly right here. In this case, it's none, so I can now say that the clutch pulley assembly of this alternator is a gunner. Think of this pulley as similar to the sprocket or drive sprocket of your bicycle. Okay, when you pedal forward, the sprocket is going to lock itself onto the wheel. You're going to have power. If you're going to pedal backwards, nothing happens. See, similar to this one. Okay, this design is supposed to be more efficient, so that way when the engine is revving, it's going to turn along with this, and when you rev down the engine, or the revolution of the RPM of the engine goes down, this here, right here, is not going to go down. The RPM is not going to drop along with the engine. It's going to supposed to freely run. Okay, now one last test that we're going to do is we are going to connect back the negative terminal, and we are going to turn on the engine. But before we do so, we are going to perform a walk around, make sure that we did not leave any tool on the engine bay. So we are going to start the engine without the serpentine belt on. Now this is the part wherein you are to hope that when you turn on the engine, the sound is no longer there. In this case, the sound is gone. So we can now rule out that the sound or engine noise is, the noise is being caused by the engine. So thank God. So all in all, that's how you can perform a process of elimination, and where you can pinpoint the exact culprit for producing that noise. So anyway, that's it. If you're wondering how to install the serpentine belt back on, it's easy. Just do everything in reverse, okay? Like so. I'll show you. Wrap the pulley, the belt over the crankshaft pulley, over this pulley of the clutch fan, okay? And under this idler pulley, over this AC compressor, okay, around this idler pulley again, then over the alternator. Okay, now this is where it becomes tricky. Okay, so we'll put it like that for a while. Make sure that every part of the belt is lined up. And then we will take our 14mm wrench and our pipe, and then we will insert it like so. Okay, and then try not to lose that. Pull the wrench upwards. Okay. Okay, so as soon as you feel that you already have overcome the tension of the spring of the tensioner, insert the serpentine belt over the tensioner pulley. Okay, so that's it. Very easy. Now before you turn on the engine, perform a visual inspection. Make sure that all the belt the center serpentine belt has lined up with all the pulleys that is going to be driven by it. Okay, so all in all, that is how you conduct a process of elimination in order to ascertain the real culprit as to what is really producing that really weird noise when your engine is running. So if you're only going to assume immediately that it is caused by a fan belt, you buy and replace it, and you're only going to waste money. So in my case, I'm already sure that it is caused by a worn out clutch pulley assembly of the alternator, which will be the subject of my next video. Now be advised, be informed, I am not a professional, I'm only a DIYer. And should you wish to emulate what you have seen here, do so at your own risk, okay? My only intention in showing you all this is that in order to provide you with a basic understanding of how your vehicle works and to perform a simple diagnosis yourself. That way, should you, if you do not want to do this yourself, or if you do not want to perform your repair yourself, should you bring this to any automotive store, automotive shop, and when the mechanics there senses that you somehow have a little know-how or a basic understanding of how things are, they would be hesitant to bamboozle you. On the other hand, if you go to an automotive shop and they sense that you are, pardon this word, that you are a moron when it comes to your vehicle, then they might try to bamboozle you and make money out of you, okay? They would tell you that you need to replace this and all that, but it just so happened that you're only going to need to replace this. So I'm not saying that all automotive shop are unscrupulous, but let's be realistic. There are automotive shop out there that is very unscrupulous when it comes to their practice, okay? So I hope you enjoyed this video, and thank you for watching.